Now let's have a look at question number 7a. Complete the following diagram if the critical angle of glass is 42 degrees. So this is a semisphere or a hemisphere which is given to you. This is made up of glass and the surrounding medium is air, and there are three rays marked, ray A, ray B and ray C. Now it is given in the diagram that ray A makes 42 degrees with the surface, whereas ray B makes 48 degrees with the surface. However, one should remember that angles measured in refraction of light are with respect to the normal. So we should not take this angle into account for ray A, but its complementary angle, which is 48 degrees out here. So we should take into account this angle, which is 48 degrees, and therefore for ray A, the angle of incidence is more than critical angle, and as a consequence ray A will undergo TIR or total internal reflection. So I will show the total internal reflection of ray A out here. Since the angle of incidence for ray A was 48 degrees, the angle of reflection will also be 48 degrees. Now, as far as ray B is concerned, the angle of incidence is not 48 but the complement of that, which is 42 degrees. So it is 90 minus 48, which is 42 degrees, and since that is the critical angle of glass, ray B will travel along the surface of this hemisphere. That is, angle of refraction in this case will be 90 degrees. So the angle of refraction out here will be 90 degrees. So ray B is undergoing critical phenomenon, and ray C is making a much smaller angle of incidence as compared to 42 degrees, and therefore ray C will undergo regular refraction of light, and since light is moving from denser medium, that is glass, to rarer medium, that is air, it will bend away from the normal. So this angle will definitely be more than the angle of incidence for ray C. Next one, an object is placed in front of a lens between its optical center and focus and forms a virtual, erect and diminished image. Name the lens and draw a ray diagram to show the formation of the image. Okay. Now, name the lens. Since the virtual image is diminished, I can be confident that the lens is a concave lens, as convex lens forms a virtual image. However, the image in such a case is magnified, which is used in the magnifying glass or the simple microscope. So here the lens is surely the concave lens, as the image is virtual and diminished, and convex lens doesn't form virtual and diminished images. It forms an virtual image, but that is magnified. The second part, we need to draw a ray diagram to show the formation of the image. So first we'll draw the principal axis. So this is the lens. This is the second focus. This is double the length of second focus. This is the principal focus, this point out here, and this length is double the principal focus. And if I have to put an object between F and optic center, this is the optic center out here, O, and suppose I call the object AB, then the ray from the arrowhead of the object, which is parallel to the principal axis, will be forced to diverge in such a way that it appears to be coming from F2. And the ray of light which goes to the optic center will obviously go through undeviated. And wherever these two rays appear to meet will be the image. So there will be a virtual image out here, and the virtual image obviously has to be marked dotted. So this is the image A dash B dash, and therefore this is the image A dash B dash, which is a virtual upright diminished image. Question 7 part C is a numerical. 1.2 kg of ice at minus 15 degrees Celsius is heated continuously till it becomes water at 100 degrees Celsius. Calculate the amount of heat required at different stages. Draw a graph of the temperature versus heat to show the different stages, and the specific heat capacity of ice is 2100 joules per kilogram Kelvin. So we need to calculate the amount of heat at each stage of heating. So let's take up first stage, which is heating of ice at minus 15 degrees Celsius to ice at 0 degrees Celsius. The heat absorbed can be written as mc theta. Mass of the ice is 1.2 kg. C of ice is given to you here as 2100 joules per kg Kelvin, and theta is the change in temperature, which is 0 minus 15. So that will become plus 15, and the answer turns out to be 37,800 joules. In the second stage of heating, the ice has to be melted. So ice at 0 degrees Celsius becomes water at 0 degrees Celsius. In that case, the heat absorbed is given by the formula Q is equal to ml. Mass is 1.2 kg, and specific latent heat of fusion of ice is given to us in the question as 335 into 10 raised to 3. So the answer turns out to be 402,000 joules. And finally, the last stage of heating, when the temperature is increased from 0 degrees Celsius to 100 degrees Celsius. So water's temperature is increased from 0 to 100. So again we can use the formula Q is equal to mc theta, m being 1.2 kg. The specific heat capacity of water is obviously different from specific heat capacity of ice. It is 4200 joules per kg Kelvin. So it is 4200 joules per kg Kelvin, and the temperature change is 100 minus 0, and as a consequence the total heat turns out to be 504. Now we need to represent this graphically. So let's take the origin as 0 joules and minus 15 degrees Celsius. So the y coordinate out here is minus 15 degrees Celsius, and the ice was heated up from minus 15 degrees Celsius to 0 degrees Celsius. So this is 0 degrees Celsius, and now the ice will start melting. So the ice starts melting and absorbs some more heat, and in that case there is no change in temperature. So this part represents melting of ice, whereas the first part represented the heating up of ice. So there was solid ice being heated. Then finally the water formed, its temperature is increased to 100 degrees Celsius. So we can represent it graphically this way, and the corresponding temperature out here is 100 degrees Celsius. So here we have liquid water whose temperature was increased from 0, which is out here, to 100, which is out here. Now we need to mark the amounts of heat absorbed. The amount of heat absorbed in the first part is 37800 joules. So 37,800 joules. In the second part, the heat absorbed was 402,000. So this heat is 402,000 joules. So as a consequence, the total heat out here will be 402,000 plus 37800. And in the third part, the heat absorbed is 504,000 joules. So therefore, the total heat absorbed by this point is the earlier heat absorbed, that is 402,000 plus 37800 plus this new excess heat absorbed 504,000 joules. So this will be the total amount of heat absorbed in joules.